what exactly has been happening earlier in the stock market. So basically, my Capstone project is based on stock market. We have seen that fundamental and technical analysis has been there in the market, and we have also seen that some of the algorithmic trading also has been going on. There's been an approach to evaluate stocks, and we have also seen some of the prediction which is happening using machine learning. So the next process was like try to understand, like go into literature and try to understand more in depth actually what has actually been happening and how is that the fundamental technical analysis has all been covered under literatures and all various different innovations and things that have happened earlier. So I have gone through around 28 research articles, out of which some of the important papers I've listed here. So like the gist of like fundamental analysis, I have one listed gone on LBD, and then analysis and evaluation of technical indicators. Then later on, I've gone tried to understand in depth about the algorithmic trading, and then I have also gone to the machine learning approach, like what exactly the literatures have talked about. So having gone through all the 28 research articles, I found some of the lacunae, some of the drawbacks from those research reviews, and those gaps were like feature expansion and elimination, like mostly which is required in the data preparation stages, where like hardly observed, and the hyperparameter tuning at the modeling stages were not actually done that properly. And even I've seen that most of the literature, when I've scanned through them, I've seen that most of them were actually trying to focus on regression-based models, where actually they were trying to predict the exact prediction of the close price. But what I was interested in is getting into the direction analysis. I tried to research on those articles. I did not find many articles. This is one of the major research gap that I observed. The direction-based analysis were rarely available. So my problem statement was that there have been plenty of algorithm which is being doing regression analysis, but classification-based modeling approach here is what I've been looking at, and I've been trying to work on that. Mostly my primary goal was direction detection. So the objectives was first I have to understand the data. Like now I have to I have number of stocks. Like I have SDFC stocks, I have Kotak stock, I have SBI stock. So for example, I've taken 3 stocks. So I had to go and examine a number of stocks, and I have to find which one is the best one for going for the data analysis, because some of the I have to go to the data understanding, understand the data how the data is working, like what's the distribution, whether it's normal distribution or not. And then after that, once having detected the right data or right data set, then I'll choose the data, and then I'll build the right models using multiple classical modeling prediction techniques, and then I'll try to minimize the errors in direction prediction. So these were the 3 primary objectives that I've been working at. So this is the kind of like a project methodology that I've tried to work around. So initially I did a data extraction for basically my focus was on different stocks like SDFC, SBI, and Kotak stocks. I took their stocks for the year 2000 to 2022. Then I did a pre-processing steps, like I did some data distribution, I did scatter plot, I tried to handle missing values, and did some feature addition, min max scalar. And then further to that, I applied modeling on them, like mostly classification modeling, the loss relation decision, all these, and then validation I tried to do using precision, recall, and accuracy. And then finally, it was deployment, which was proposed one. Actually, it's a proposed one for the future implementation, where we can develop some state-of-the-art API design. Maybe we can use a Qt-based Python approach, where backend we have all the Python algorithm, Python functions, which are taking care of like finding out what all like modeling accuracy and all data preparation, data this thing, and all this will be done in the backend by the Python. The Qt, the graphic end will take care of the dashboard part. Then the business understanding, going for the business understanding, I try to go with a stock fundamental analysis initially to understand like how these 3 stocks which are under consideration for my capstone is going on. So like there are only few of the elements that I've listed over here. That net profit, if you see, the net profit is 369. The numbers are in billions, actually 369 billions in SDFC. The net profit is there, whereas Kotak it is 85 and SBI is 316. So all of them shows a very healthy trend, and that's why the stocks, whether at the time of stock selection, I found that okay, these 3 stocks are the one where I can go for the analysis and try and find what is my prediction accuracy, especially for the direction detection. Then I went for the technical indicators also. The fundamental analysis was for a for a longer period of time, like for year to year. I try to do fundamental analysis, but technical indicators are were done on a weekly to weekly basis. So here are some of the latest technical indicators which are given on a weekly basis, and this was recorded on 10th March 2023. These technical indicators. So from the technical indicators, we are seeing that HDFC is showing some bullish trend, whereas Kotak is showing bearish trend, whereas SBI more or less it's showing bullish trend. And the indicators that have been used here is momentum indicators and trend indicators. So these are the latest weekly analysis. For the next week, things might undergo a change. Then these are the data that I have used for my modeling purposes. So here are these are my feature variables, that is previous close, open, high, low, last, VWAP, volume. So these are all my feature variables on which I'll be doing the modeling, and on top of that, the close is my target variable or destination variable on which like I'll decide the direction detection, like where exactly, how, whether it is going in a forward direction or it is not going in a forward direction. So if it is going in a forward direction, I'm going to put my bet on it. If it is not going in a forward direction, then I'm not going for it. So that is how, and my area of concentration will be like where it is going forward in forward direction. So looking forward in the data understanding, I see that from in the 2000 the close value was around 294, and from the 294 it has gone to 2367 on 5/30 2022, which shows a very healthy trend. Again, it's a upward trend for Kotak also, for an upward trend for SBI also. So data understanding also seems to pass, and that is the reason why I have chosen these three stocks for my consideration. Now, while going for data preparation, like I had to add some newer feature variables because I can see these are the primary feature variables. These are the primary feature variables which I have been using. But on top of that, I added some newly feature variables that I added 13 days, 20 days, 100 days, 200 moving simple moving averages, exponential moving averages, 1 day previous lag of values. And then I added 6, 10, and 14, 30 days close prices. These are the new feature variables that I added in order to do my analysis. And then momentum indicators, trend indicators, volatility indicators, volume indicators with the new feature variables. Now these feature variables, like I had one Python application which was already available, which was giving me all the momentum indicators data values, all the trend indicators data values. I was using those indicators values, and those indicators were used as feature variables where the directional close price was actually the target value, and on that target value I am doing the prediction. Okay, and then one of the other data preparation stage was min max scalar, where I was reducing the value range from 0 to 1. Why we are doing is because HDFC, Kotak, and SBI, we are taking over the range from 2000 to 2022, so there are a lot of variations. So in order to take care of that variation, we are using min max scalar, and then there were some missing values which we had too many of values missing, so we dropped them. Now in descriptive analysis, we see here that basically our design was like, suppose if there is any if the previous day of close price and the next day of close price, if the difference is more than 0.5%, so I'll say that okay, it's a healthy trend, and I'll go for the stock is moving in a forward direction. If the current day value and the previous day value, the value is less than 0.5%, then I'll say the stock is not moving in a forward direction, so I will not take any step in that. Like I'll not be I'll not take a buy position. So basically my area of analysis was this one, where number of days where the stock has risen by 0.5% from the previous day. So if the next day and the previous day, if the rise is 0.5% or greater than 0.5%, there is where I have to make the decision, and I have calculated the direction of the thing, and then based on the direction which I have taken as a target, on that I have done the modeling, and I try to find out what is the precision in predicting number of ones, predicting number of true positives. These are trends that have been available from 2000 to 2022. So we can see that Kotak shows pretty healthy trend, whereas HDFC somewhere SBI in between they have shown also a slump. Now in discrete analysis, I've also tried to see all the density plot, which shows that positive skew distribution is there for all of them. And then we can see the Kotak has got the highest volatility because there are a number of data points which are very varying over here. In case of linear relationship exists when we see the scatter plot for all of them, when we plot the scatter variables for all the feature variables versus the target variable. And from the box plot, we can see that there are some outliers which are only available for quoted data set. For other data set, outliers doesn't seem to be visible, though there is a positive skew distribution which can be visible from the box plot analysis as well. Now, modeling strategies. Now, let me go to the modeling strategies. So, what has been my modeling strategies is, initially I have gone for the direction detection. First, what I have taken is that I have taken 6-day lag variables. That is, I have taken 1-day lag variable as one of the columns, as one of the feature variable, 2-day lag variable as another feature variable, 3-day as another feature variable, 4 days another feature variable, 5-day lag variables is another feature variables. This way, I have the 6 feature variables. On top of that, I have the 7th-day lag variable and the 8th-day lag variable, and I have taken a difference between 8th and 7th day, and then I have also taken a percentage difference between the 7th and 8th day. And if the percentage difference is greater than 0.5%, actually we had different strategies. We had seen whether the whether strategy is going to give me a better accuracy for 0.5% change or 0.7% change or 1% change or 1.5% change. So for all of these data sets under 3 data sets under consideration, I have seen that 0.7% change was giving me a better prediction accuracy. So this was actually helped me in doing the direction detection, that whether it is positive trend or negative trend or neutral trend. Then after that, on top of that, now I want to take a decision. So for taking a decision, I want to go for another approach where I have taken momentum indicators. I've used them as feature variables, and I have taken the target value of the close price, and I've seen the percentage change of the close price, whether it is 0.5%. So if the percentage change is greater than 0.5%, then I've said it's a positive trend, and there we can make a stake over there. If it is not there, then we'll say not positive trend. And for that, we have designed the algorithms differently for different indicators. That is momentum indicators. We have taken all feature variables, momentum indicators, and on top of that, we have done a prediction accuracy. For trend indicators, we have taken all trend indicators as feature variables. Like there were some 10 to 12 trend indicators. So all the trend indicators we have taken as feature variables, and on top of that, we have done the prediction accuracy. Then for volatility indicators, we had some 10 to 12 volatility indicators. So we have taken all those 10 to 12 volatility indicators as feature variables. On top of that, we had done a prediction accuracy. For volume indicators also, we have some 10 to 15 volume indicators. We have taken them, all of them as feature variables. On top of that, we have tried to see what is the prediction accuracy. So we have plotted a prediction accuracy for all of them separately, like 4 different kind of algorithm modeling approaches we have done. For momentum indicators, we have taken a modeling approach. For trend indicators, we have taken a modeling approach. For volatility, we have taken a modeling approach, and volume indicators, we have taken a modeling approach. And then out of that, like whichever is most suitable, like for all of these 4 different modeling approaches, we have used 5 different kind of modeling algorithms. Like we have used logistic regression. For decision tree, again, we have different flavors. We have used different flavors. We have used decision trees in grid search CV. We have used cross validation. We have even used randomized search CV and cross validation for random forest. And then we have used k nearest neighbors, and we have used XGBoost modeling algorithms. So these are the different classification algorithms that we have used for our 4 different kind of modeling approaches. Okay, so in aid of data preparation, how we have actually processed it, how we have moved actually is, first initially we have done like as I have said that first initially we had done this mean max scalar. So after getting the mean max scalar, then we have done the principal component analysis. So principal component analysis, what it has done is, it has given me reduced number of variables, because when we have done the feature variables and we have done feature enhancement also, so on top like combining all the feature variables, it was coming as like for any modeling we were getting some 15 to 20 feature variables, and on top of that we had to do modeling. So before doing the feature modeling on those feature variables, we want to do a PCA, so that our variables get reduced, and we can see that the correlation between 2 variables should be minimal, and in intra correlation should be more. So for that we have used the PCA modeling approach. That was an unsupervised modeling approach, just to reduce the number of variables on which we want to do the modeling. Once we have reduced that using PCA modeling, on top of that we have applied all the different classification approaches. So after that we have got the model evaluation results. So here we can see that for the volume indicators, we can see that logistic regression approach, we are getting some precision 98, precision 99, which looks to be a very, very high precision, which can be, which is being given logistic regression, which can be used for high risk investors. Suppose if the investor is a moderate risk investor, then he can go for 83 precision, so which is been given by trend indicators. Using logistic regression modeling algorithm only, trend indicators has given me a precision of 0.83, whereas the logistic regression for using volume indicators has given me 98 accuracy. For some still an investor who is not still who is looking for least amount of risk, then in that case he can go for the momentum indicators where the precision is 71. So our approach was that we wanted to see a precision coming for between 70 to 80%, not go more than 80%. If suppose it is going more than 80%, we have given the choice to the investor that whether you want to invest on that on that or not. Because stock market, as we know, a lot of volatility is a concern over there. So 70 to 80% accuracy, if you're getting over there, mostly I was now interested in precision rather than accuracy. Because if I'm getting 70 to 80% accuracy, then we can get a good amount of returns with the least amount of risk possible. So this is the modeling algorithms that we have used using logistic regression. Similar approach we have followed for the random forest also, for XGBoost also, and we have the other one that is k-nearest neighbors also, and we had used decision trees also. So for the lack of space, we have not put all the tables over here. We have put some of the key tables over here to give a gist of like what exactly whether things that were there in now that we have to take care while doing going for the model evaluation phase. So after completing the model evaluation phase, we came to the results and insights where we have different modeling methods. As we know that we have done direction detection. So direction detection we have done using different modeling algorithms. RF classifier has given me the best precision accuracy figures. Whereas when I do volume indicators, loss regression classifier has given me the best precision. If I do the momentum indicators, I see the random forest classifier has given me the best precision figures among all the other classifiers. That here also we have used random forest, here we have used distant trees, here we have used lossy regression. We have used all the 5 different modeling algorithms over here also, over here also, over here also, over here also, over here also. So out of that, the best one in each of the modeling mechanisms, we have taken that and we have plotted that in our results table. So this is the leaderboard which shows highest prediction accuracy for each of the different modeling methods. So after getting the results, like what is the takeaway? Some from utility from the business perspective. So if you're trying to understand, like if you go for the trend indicators are giving me the highest precision of 0.85%. So if I see here, trend indicators using XGBoost classifier has given me the highest precision of 0.85%. So if you see here, this is the precision figure. That is, we are seeing that now out of these many predictions that has happened, so we are not interested in what was the prediction 0 is there. We are interested in what was the prediction 1 is there. So out of the prediction 1, 319 has been correctly predicted as 1 and 56 has been incorrectly predicted as 0. 0. I mean, actually they were 1, but they were predicted as 0. So this is actually the loss. Now this is the kind of loss that we are going to see. If we invest rupees 10,000 for 6 years and we are seeing 0.5% change, so this will give me the loss, but this will be the profit part. So if we just see here over here, so this is the formula we have used, and we can see here that we are getting around 31.5% return. Like if you are investing 10,000 rupees for a period of 6 years, why 6 years? Because we have split our test and train. We have split our test and train for 70%, 30% split. So last 6 years is our test thing, and where we are doing the accuracy. So accuracy results, we are getting 18.63% return. Sharp ratios, again, we have got the HDFC, the highest sharp ratio means highest return with least risk possible. Model deployment is later. We can deploy this model. We can use a Python Qt model, as I have talked earlier about all about. Conclusion future work is like we can still do the automation system on option trading. We can later on we can have a deployment dashboard like where we can use the Qt and we can use the Python for doing all the modeling algorithms, and we can also define bullish and bearish regimes, because here we have not taken bullish and bearish regimes. Some of the time market will crash, at that time we can say it's a bearish regime. Sometimes the market will be going very healthy, at that time we can say a bullish regime. So we have to define bullish and bearish regime period, and then on top of that we can do all of these modeling approaches. Then sentiment analysis approaches also can be explored using text analytics. So yeah, this is all a gist of like whatever I have done. So back to audience.
So, Anand, one question. I mean, you started off saying there are not enough classification models. There are classification models, right, to predict whether a stock would go up, down, where it's a hold, buy, all of that stuff. There are models that are present.
Yes, there are a lot of modeling classification model approaches are there, but the way the kind of detailing which I've tried to go, trying kind of feature expansion that we try to go, like I have taken like 1 day lag variable, 2 day lag variable, like using this classification model, like these modeling algorithms were there, but the approaches that I have tried to do is very unique ones, like using using all the indicators, using all the indicators and trying to find 4 different modeling approaches using that. I mean, the classification modeling algorithm is the same, but I've tried to build some newer approaches, which is like the most like newer innovations in case of like direction indication, like where I want to know like whether it is going high or it is not going high, whether it is going in a forward movement or is not going forward movement. If it is going in a forward movement, so I know that if it is a going forward movement, if I've taken a bet over there, then it's always a 0.5% change. So my previous capstone was based on the prediction of the close price, but the close price, like sometimes suppose if say that close price is 20 rupees and you make a bet on 20 rupees, you might lose for that. The probability of chances of losing is more over there. But if you are betting on more on direction analysis, so at that time there's always a 0.5% bet returns that you're always going to get over there. So that is why I try to do more extensive research, more intensive research on like the approach that I can use in classification for direction detection especially.
Okay. And just to be clear of the Y variable in this case, you're basically saying, would it generate X amount of return? Is that what it is? What is the Y variable here?
Which one?
So when you do a classification, the Y variable that you're trying to predict.
Uh-huh. Okay, let me show that what I've done over here. So these are all the different lag variables that I've used as a different feature variables. Okay, so these feature variables were derived from the actual close price, the actual close price which we
Okay.
had. So
The
on
target variable, what is the definition of 1, 0, -1, etc.?
Yeah, so if the percentage difference is greater than 1.5%, like here we have different, like we have now one approach is that we'll look for 0.5% change. If the 0% change is 0.5%, greater than 0.5%, then we'll make a target as 1. Other approach is that, okay, 0.5% has not given me a better accuracy. Let me see for 1% change. If suppose the previous 1% change is there, on that if I do the modeling, whether I'm getting a better accuracy. If not that also, then we can go for 1.5% change. If that 1 point, so now I've done a lot of variation on that. Like here you can see that this is for 0.7% change. So you can see that the percent change is 1.16, which is greater than 0.7%. That is where target is 1. If see here you can see less than 0.7% change, so target is 0. Here it is again less than 0, so target is 0. Here again the target is more than 0.7% change. So here it is 2.73%
And
change. So that's the
and
one.
sorry, the basic 0.7% change with in terms of the stock price, you mean over what period of time?
In terms of the close price, previous day close price. So here, like here, I have taken 12 this thing. Okay, so these 10 are my feature variables. So D1 to D10 are my feature variables. D11 and D12 for is the 11th day and 12th day. Okay, and for that I've taken a difference, and then I have plotted a percentage difference based on like now what is the what if the difference is this, so over D12 what is the what is the what is the percentage difference that's coming out. Okay, so here I have taken 10 days lag variables. So similar way, I have another variation where I have taken only 6-day lag variable. And even I have taken 14-day lag variable. For that, I have taken, I have done other modeling. So the whole purpose of doing so many modeling methods is I want to see which one is giving me the best prediction accuracy. So if suppose none of these modeling approach will give me the best prediction accuracy, suppose my prediction accuracy remain around 60% or 50 to 60%, I know that I have to abandon this stock. I don't have to go for this stock. Maybe I'll go for some other stock where I'll see at least 70% accuracy getting. I'm getting for all one of the variations is giving me at least 70% or 60 to 70% accuracy. Then I can go for that stock, and then I will go for all different technical indicators. On top of that, I will do the prediction accuracy again for based on that.
Okay, all right. Thank you.
Anand, couple of things here. So, apart from the data visualization that you are showing on the Jupyter notebook, do you have anything else like an UI that you created, or this is the final delivery that you have done through notebook only?
Yeah, so this is just the implementation.
Hmm.
My body is echoing.
I can hear you. I don't hear any echo.
Okay, so this is just the implementation that I've done only for three stocks. So when it will come to the deployment level, at that time it will
Hmm.
not be the three stocks, it will be more than 700 stocks, or say, no, if I take an NSE stocks only, we have around 1600 stocks. So I can
Hmm.
put all these 1600 stocks, and of the 1600 stocks, I will generate an API. That API will say that, okay, this stock has given me 70% prediction accuracy, so this stock is good to go. So out of 700 stocks, or out of 10,000 stocks, I'll get some, suppose say 100 stocks where it will say that, okay, this 100 stocks have given me 70% accuracy, is good to go. So from that I can, the investor will have a better opportunity. But yeah, I have not developed a deployment level, because at deployment level you require, more and more amount of bandwidth and more. So I have tried to restrict myself with only these three stocks. So my area of research was only HDFC, SBI, and Kotak stocks. Like we
Hmm.
have now, like if you try to scale it, then later we can go to the deployment level where we can employ more than 700,000 stocks over there, and then we can get a, kind of a, which achieve a good, market objectives also. That, as I said, like one of the formulas I applied, and with that formula I'm getting 18.63% return. So utility from the business perspective is also good, because you're fixed. If you put your money in the bank, a fixed deposit also will give you hardly 7.5%, or no, it will be around somewhere around that. But if you are getting 18.63% returns, and I'm saying that because I'm trying to limit myself with 70 to 80% accuracy, so my returns also will be quite consistent, because I'm not going, I'm taking into account the volatility that they existing in the stock market. So I'm not going beyond 70 to 80% accuracy. Wherever I'm getting 70 to 80% accuracy, I am trying to, pitch for that, and even pitching for that, I'm getting around returns of 18.63%, which is quite good. If you look from the business perspective. And then I later on I also even calculated the SARP ratios. So SARP ratios also we can see that 0.17 means HDFC has got the highest SARP ratio, means it is the least volatile stock with the highest returns.
Okay. Okay, but when you expand, so one of the ideas when you want to take it to the next level is expanding the base. Like currently you have three stocks, you will expand the number of stocks. Any other ideas, anything else you would like to cover in the next iteration?
Yeah, the next iteration I've also said that now I have taken analysis from 2000 to 2022 years period. Now I want to divide this different period between the bullish periods and the bearish periods. So maybe
Okay.
some, maybe 2007 to 2009 was a bullish period where the stock was going very high, because 2007 to 2009 we know that the stock market has crashed. So at that time we can say that it was a bearish regime. Similar way, we can have some bullish regime where the stock has gone very high. Like right now, if you see the stocks has in the bearish range, like it is not moving high. So this can be called as a bearish period. So we can categorize into bullish and bearish period also. So that is another approach. Another approach is like finding out the sentiments from the, from the Twitter handle, from all that, and find out like from there, what is the accuracy you are getting from the tweet, from all the tweets that's available. So sentiment analysis. So that can be that is another future implementation that can be taken up over here.
Okay. Okay. I think I don't have any further questions. You're good.
Thank
Yeah,
you, Anand. You may drop off now.
yeah. Thank you.
Now we have a last